All right, so today we're going to do the grafting lab. So I'm going to tell you a little bit about grafting, and then I'm going to show you how it's actually done. So first of all, you may ask, what is grafting? Grafting is when you're going to combine basically two different plants. Now, when I say two different plants, I don't mean two different species. I mean two different varieties. My illustration down here, we've got genotype 1. This is a normal plant. So this is a plant that just has, it's on what we would call its own roots. Over here, you've got a plant that is grafted. It's what we call a low graft. So you've got one variety here and you've got another variety down here. Then here we've got something called a high graft. Then over here we've got what we would call top working. So you can actually have a full-size tree and you can graft on the top part. Then over here we've got this top part, then we've got something called an inner graft. This is sometimes called double working. So the scion is the part on the top here, and then this is going to be the stalk or the root stock. So whatever is green here, that's your scion. The red in this one is basically going to be your stalk or your root stock. So that's what you're doing, is you're actually combining these two. And the way plants grow, because they grow from the tips, the fact that this is different is not going to change what you get up here. Okay, so why do we do grafting? Grafting is used for a number of different reasons, sometimes just to propagate, just to make more of a plant, to clone it. So this is a type of asexual propagation. You can also use it to enhance disease resistance. You can change the size of plants. You can get plants to produce their crops faster. And you can combine different varieties of a tree on one. You can get, say, for example, a Granny Smith and a Red Delicious on the same tree. Or you can change varieties. You say, you know what, I don't want to try that variety, I want to try something else. You can graft something onto that tree and try it. There's a news story somewhere of a guy that actually had a tree that's had something like 200 different apple varieties on one tree. Now the problem was he only got 1 or 2 apples of each variety, but you know, it's a thing you can do. But pretty much anything that's a fruit tree can be grafted, like apples, pears, mangoes, cherries, peaches, figs, persimmons, all kinds of other things. Nut trees like pecans, walnuts, and chestnuts. Grapes are very commonly grafted. Occasionally people do this with vegetables, especially if they're grown in a greenhouse, mostly because the grafts, if you're going to bother to do it, you want it to last a few years. If you do it on a tree or a vine that's woody and is going to last for many years, it's more valuable. So vegetables that only last for a few months, it's a little less common, but it's becoming more common. Also ornamental plants like cherries, especially trees that are weeping, they'll graft those on what they call a standard. Roses are almost always grafted. So what do you need to graft? You need usually a dormant scion and rootstock. There are some exceptions to that, especially in tropical plants. But in most plants, we're going to do this in the early spring when everything's still dormant. And all you really need is a sharp knife and something to wrap the graft unit. You can use parafoam, you can use rubber bands, you can use wax, some people use string. This has been done for thousands of years. It's actually mentioned in the Bible. So grafting is actually, you know, it's not an unusual, really weird thing to do. It's something people have done for a very, very long time. And you can use pretty much anything to wrap that graft unit as long as it keeps a good contact between your scion and your rootstock. So our types of grafting, so you have wedge graft, saddle graft, chip budding, and whip and tongue. There's actually a lot more than this. There are more types of grafts than you could almost imagine. But the wedge graft, basically you just have your scion makes a little wedge, and then you make your rootstock have a matching structure here. And basically what you have, we actually will do this with a grafting machine. There are other grafting machines that can make something called an omega graft, which makes it look like the Greek letter omega, and can put these together. But you can also just do this with a knife. The saddle graft is very similar to the wedge graft, but the difference is the scion kind of looks like a saddle. Now the secret to both of these, pretty much all grafting, is you have to be able to line up the vascular cambium. The vascular cambium, as long as it's the same species, it'll grow at about the same rate. And because of that, the vascular tissue will stay in contact, and the rootstock can support the scion. So you have to keep these at about a very similar diameter. So this part needs to be similar in diameter to this one. Chip budding, you can actually make lots and lots of grafts from one twig. This is what's most commonly done in apples commercially. So basically you'll just cut this chip out, you'll cut a little hole into your rootstock and you'll stick it in there. And basically wrap them together and it'll make it. When we did this last year in class, we didn't get a really great take, so we'll have to see how the grafts that I'm going to do will do. But you can also use this when you have different sizes of scion and rootstock. They don't have to be exactly matched. Whip and tongue, this is kind of one of my favorites because, at least for my hands, it seems to be a little bit easier to do. It sticks together really well. Some of these others, they tend to slide apart a little bit more easily. So basically you just make an angled cut and then you make what's called a little tongue going back in. And then basically these will fit together. And then once you do that, you just wrap them up and hopefully your graft will actually take. So just like the other two that we've talked about, other than the chip budding, these have to be similar in diameter. They won't want to be too far off. All right, so next thing we're going to do is I'm going to show you how to actually do some of the grafting. Right here, these are our scions. So they're different varieties. I bought these commercially because I didn't have any trees to take from. Hopefully I will in the future. And these are the scions, so each of them is labeled. So this is King David. This is another one called Wine Sap. So I've got Wine Sap, King David, Wine Sap, King David. And I've got one other one, which is Liberty. So these two are Liberties. So that's the name of the apple. Just like you've heard of probably Granny Smith and Red Delicious. These are all different apple varieties. And they are all propagated asexually. So if you like, for example, Gala apple, every Gala apple you've ever had is a clone of every other. And how we do this, we take the scion and basically we're just going to cut it and stick it to the rootstock. You say, how does that work? Basically, plants don't really have an immune system in the same way that animals do. And basically, when you stick them together, as long as they're closely related, or in this case, the same species, apple, domestic apple, when you stick them together, as long as they're about the same size, they'll start growing together, and they'll actually stay that way for years and years and years. So grafting is very frequently done, not just to propagate, but also to give the apples different characteristics. Especially edible apples, people will graft them on what's called a dwarf rootstock. This is what's called, this M111 is what's called a semi-dwarf rootstock. So it'll make the trees a little bit smaller. That makes them produce fruit a little sooner, and it can give them some disease resistance. So that's one of the other reasons why people will actually do grafting. And like I said, they do this with apples, they do it with pears, they do it with oranges, mangoes, avocados, pretty much everything you can think of probably comes from that's come from an actual tree, comes from a grafted tree. So I'm going to show you 3 techniques in just a second. All right, so one of the ways you can do grafting is with a grafting tool. And these have been kind of proliferating the internet quite a bit. This one's actually more complicated and expensive than some of them. I used some of these when I went to Purdue University. If you have a big orchard and you want to graft a lot of your own trees, these can be useful. I have had pretty good success with them, but they're very touchy. They really need kind of a larger, fatter twig, and they have to be kept really, really sharp. And mine, unfortunately, is already not especially sharp. So we're going to see how it works. Now, one of the things you have to do this, to do any kind of grafting, is you have to line up your twig with the tree you're going to graft onto. So we want to see that they're approximately the same size. So it looks like these two are a pretty good match. So in terms of the twig diameter, because they have to match together. And the vascular cambium, you guys may remember, that's what produces the phloem on one side and the xylem on the other side. Those have to line up, because if they don't line up, basically they won't produce the xylem and the phloem in the same place, and the graft will fail and the tree will die. So this is why we have to get those lined up to have about the same diameter. Okay, so I'm going to put this guy in here, so he should be pointing down. So I always want to cut a few inches from the bottom, because especially since this one's been sitting around for a while. This takes a fair bit of elbow grease. See that right there? Notice we've got a nice wedge. What this grafting tool did badly is it kind of mashed this part of the bark, and that's not good. So I may have to fix that a little bit. Of course, you can do this by hand. So I think we picked this guy. Now I need to make sure, since this is a pointy end, I need to make sure this guy's going to make a bottom end. Like this. So probably about, go ahead and do it about right there. Hopefully. I won't screw this up too badly. Okay, there we go. So I had to finish it off with the knife. Kind of see right there that I have now basically the bottom. So the idea is put it nicely together. So notice that you can see where that place where I damaged the bark, it's not great, but this side looks really good. They're just fitting together just perfectly. I don't want to touch those cut ends because I have oils on my skin. Pretty good. And hopefully that graft will take. Hope so. So we'll see how that works. So that's a Liberty graft on an M111. All right, now the other way you can do this is basically you can do something called budding, and you can actually just take a bud. So this is another one of these scionwoods. This one's called King David. So this is King David. I actually bought a full tree of this, but I'll see if I can do a bud. So what I'm going to do is I'm going to do a top cut like this. I'm going to do a bottom cut like this. You have to be really careful here. You never want to touch that bottom bit. Oops. So now I have a spot there. I'm going to take this guy, and again, I don't want to touch it. And now I just use the knife. Go like this, and again, like we did before, to try and line these up as best we can. You can make this bigger. We don't really want much wood showing there. See that? Alright, so I've kind of made matching cuts on these two. It's not perfect, and again, just like all the other grafting, we don't want to touch these two. So notice I can kind of line them up. Now, this by itself would just be a splice graft. And if you were working with a plant that was very fleshy, like a tomato, you could actually just kind of stick these together and hope for the best. But with woody plants like an apple, or pretty much most of the types of grafting, a lot of times we make this more expanded with something called a whip and tongue. So these two are what we call whips. They're just a single stem, and then we're going to make the tongue. So the tongue is basically a little flap that will help these two hold together. Let's see if I can do this. And what you want to do is use your knife. And unfortunately, you have to go towards yourself, but you got to do it really slow. Just kind of wiggle along just like this, very gently, so that you don't slip. Because not only could you cut yourself, you can actually screw up your scion. You want to go pretty deep. So notice now I've got a little flap right there. A little flap. That's what gives it that characteristic zigzag. Let's see if I can do the other one. Try to line it up. And I'm going to try to just very gently wiggle this guy. Not too much. And we don't want to cut all the way through. So I've got a little flap right there. Then what we do is we take these two pieces and I push against them and try to open that flap up. And we make kind of a little zigzag. These did not match up super well. Cut this one a little too shallow. So I'm going to try to do, end up cutting kind of a second flap on this guy. Try to get these to match a little bit better. It's not perfect, but better than before. So you can see there's kind of this little zigzag going on. And these should all stick to each other, hopefully. That little white stuff right there is a little bit of the label that's left. So what I'm going to do, wiggle this just a little bit further out. There we go. I'm going to try and mash this whole thing together with, of course, some parafilm. So we'll wrap this up with parafilm, and maybe it will take. All right, so here's our, that's a great whipping tongue. The main thing is you want to make sure you have contact with the two twigs. Two twigs need to be in really tight contact with each other. That's basically the purpose of the parafilm. The nice thing about the parafilm is the tree can actually, the buds can actually grow through it. So you don't have to come back and take it off. As the tree expands, it'll basically grow through it and it should fall off. There we go. There's another graft. Alright, so I thought I'd show you guys this example. So this is actually a persimmon variety known as Elmo. So this is a native persimmon, but this was actually done, you can tell this was done with a whip and tongue graft. So if you notice here, kind of see here, that's the remains of the parafilm. And if you look carefully, you can see how there's an angle right here. And you can see all of this stuff right there. That's actually where the graft union is. So this is understock down here. This is scion up here. So this is the Elmo variety that we want. And you can tell it's kind of got this little zigzag thing going on. So it's definitely originally a whip and tongue graft. Alright, so I pulled off the rest of the parafilm, and you can really see right there this nice zigzag. That's the whip and tongue graft. So these are the two tongues that were in there. So the upper tongue, right there, here. These are the two tongues. Come on, focus, you bugger. Tongue number 1 from the understock. Tongue number 2. And this is kind of the overall slant of the whole thing. So that's a whip and tongue graft that's now healed and basically produced a whole new grafted plant. So you can tell it came up from the bottom here. This is probably just the little piece that was grafted originally right there. And then it produced this big, long stalk going all the way up. Well, okay, right there. That's the terminal bud right there. So eventually, this whole thing will be a tree. Now, the only thing that's bad about a grafted tree is if anything above here dies, I lose that tree. I lose that variety. And I'm stuck with whatever this is. And I'm sure it's just a seedling persimmon of who knows what. So grafting can be a very useful, and in some plants it's almost the only way of propagating, especially in things like pecans. Actually almost always grafted or grown from seed.